All right, welcome back, everybody. Et210, Sustainable Engineering. Today we're going to talk about geothermal. Geothermal is not one of the leaders in renewables, but it's one of the very consistent renewables. It has been around a long time. It's a very small percentage of our electrical generation, but we use it for other things like heating and actually cooling because we can use the refrigeration process. But before I get into that, let's just take a look at a little graph and put it in perspective. This is about the most current one I could find, but what I like about this one is it does show you the renewables, hydro being a big one, and then the green is wood, that's like a biofuel. Hydroelectric, oh, blue one, yeah. Waste, I don't know what they're talking about there, but solar you can see is that yellow, and you can see how it's opening up. There's the gray geothermal. It's been the same for a very long time. And then biofuels is right here on top. Again, it's opening up. So if this went on, to 2022, solar would have opened up a lot, wind had opened up a lot, and these biofuels have opened up a lot, and geothermal stays consistent, not changing much. Why do you think that is? Well, because there's only a certain amount of geothermal energy on the planet, and we've tapped into most of it. So it's very location specific. So geothermal energy places third among the renewables if you count it all, including heating, cooling, and electrical generation. Okay, so it's pretty big. There's different kinds. There's low temperature geothermal. Geothermal is heat, right, from the earth. So think about if you've ever been to like Yellowstone, they have very hot shooting geysers, right? That's geothermal energy. In this area, the Ring of Fire, our Cascade volcanoes, has a lot of geothermal activity underneath there, lots of ground heat available. So if you're in an area where that ground heat is, you can tap into it, pull that heat out, and create electricity or use it for heating and cooling of buildings and structures and even roadways. I'm going to show you that in a second. How it works is right here. You're going to want to watch that because they explain the cycle of how it works. Like, what do we do with this heat when we pull it out of the ground? High temperature can be like 302 degrees Fahrenheit. That's going to flash water, right? So when you flash water, you make steam, correct? And then you can just go into a steam turbine and spin a generator, right? That's what all of these renewables do other than solar is they spin a generator. But other things you can do with it. Here's an example. This is where I went to school in Klamath Falls. They have lots of geothermal activity in the area. They have geothermal wells throughout the city. And then they have piped in this geothermal heat into buildings to heat it. So that's not creating electricity, but that's saving a lot of energy. So that when that all gets counted into the equation, geothermal can be fairly big. But they also pipe it around because even after you produce energy with it, like use it to create electricity, you have some very hot water left over. So they actually pipe it around the roadways and keep several of the downtown roads thawed out all winter long. Klamath Falls has a pretty cold winter, so that's pretty fun. Here's a picture of it when I went to school. They have plumbed it around the OIT campus. So when we get a snowfall, everywhere that there's geothermal under the sidewalks, that doesn't get snowy and icy, it just stays wet and easy to walk on. So OIT's done a good job of tapping into that. And you can see that they're going to be self-sufficient once they get their next big generator online. They're going to be able to completely negate all of their electrical costs on that campus due to the geothermal energy under the ground. So fascinating, very cool. All right, so let's just talk about heat pumps because you can use geothermal energy to improve your heat pump, right? You can use just the ground energy. So if you dig down in Oregon, a couple feet, you're going to get 50-degree ground. that's about our temperature in this area. So, you know, if it's 20 degrees outside, 50 degrees feels pretty good. And if it's 100 degrees outside, 50 degrees feels great. So you can take that huge energy mass of the ground and you can use that to both heat and cool. Like on a cold day, 50 degrees feels pretty good. And if we can use 50-degree air to supply to our heat pump, it doesn't take much energy to get it from 50 to 68, maybe what we want our home at. So it's a great heat sink, holding heat, and it's a great way to cool also because you can do the same thing on a very hot day. So that's what heat pumps are really good at. So the way a heat pump works, just in basic form, I want you to watch that video to try and get a little more information. But what you have is a fluid that you're going to send in a circle. And as it goes through different phases, energy either gets absorbed or energy gets expelled. Okay. So let's just start. Let's start here and say we have some hot fluid that we're going to send through the compressor, right? And then we're going to blow air over this condenser. So as this hot steam condenses into a liquid and heads for the expansion device, a lot of heat can be extracted from that maneuver. It's the same way we cool our bodies when we sweat, right? That evaporation will also cool you. So as it comes around, sent through an expansion device, sent into the evaporator, we blow air across it and it'll cool that fluid big time. So then as it comes around, so we compress it back up, that'll heat it and send it around. So you can have both a heating and a cooling mode in a heat pump. That's why they're so beneficial. They do use the air and pull the energy out of the air to create that kind of a process. So this is where the energy is obviously put into the system. You have to spin a compressor to get it to compress. So that's going to take electrical energy. And it's going to take energy to blow the air across the condenser and across the evaporator also. So, you know, you do have to put energy in to get your cooling and heating out, but it's pretty efficient because it's this closed loop cycle. All right, so what's it look like more in a kind of a schematic form? You'll have a condenser. It'll take this hot fluid, right? And condense, it'll take a cool fluid, condense it and heat it up, right? And then send it around to an expansion valve. So if this is where, you know, if you want heating, this is where you'll pull the heat off. So as it comes around, we send it through an evaporator and this is where you'll cool it. So as we blow air across, it's just going to blow cold and come back, and then we'll compress it and heat it up again. So that's kind of the basic simple refrigeration system. The way a geothermal heat pump would work is it would take the warm, if it's a cold day, right? It'll take the ground temperature and pull it into a pressure tank, and then the heat pump will do work to that. So depending on, you know, whether you want a cool cycle or a hot cycle, basically here it's a preheater for the winter, and here it's a pre-cooler for the summer. So it's just helping the system in both situations. What's it look like? Well, on a residential platform, it can look like this, where you dig a big pit and you put a bunch of piping in the ground so you can run a fluid through that and get to your 50-degree fluid, right? That'll assist in both the cooling and the heating. So it can be a horizontal system like this, and it can be a series of vertical down pipes like this diagram on the left. So right here is low-grade heat explained. If you want to click on that, it'll go into more detail about how you can do this geothermal thing without having hot rocks, right? Just using ground temperature can be effective. All right, here's a very fun example of a big project we have in Portland. It's the Port of Portland administration building out at the airport. They have all of these longitudinal pilings that they can pull the ground heat out and use it for heating and cooling in the building. It's a fantastic structure. It's very efficient. It was not cheap. It does some water filtration, has a living digester, a plant system that all the gray water, like when you wash your hands, gray water, can go into and get cleaned and come back out. So heating and cooling geothermal pilings, which does a great job. It also has solar, and this structure is very energy efficient. So that's kind of how it could work. All right. This is a fun video, kind of a how to boil water to make ice. And this is going to give you another idea on kind of how evaporation works and condensation. So check that out. And this is your little homework assignment that's posted up on Blackboard for geothermal. So watch these links to get a feel for it. And before you answer the questions, make sure you go through those. All right. That's it for geothermal. It's such a small portion that we're not going to spend a lot of time on it, but you should know what it is. And we'll do wave on Wednesday.